Everyone, it's time for Math Skills. I am Tamika Lodge Fenton. Today's topic is ratio and proportions. Let's begin. So here we're in the unit ratio and proportion, and this unit's aim is to develop skills in reading and using scales, ratio and proportion. For this lesson, for this session, we want to look at reading and using scales on maps and plans, as well as use inverse and direct proportion to solve real-life problems and write as a proportion the relationship between two quantities. All right, as usual, let us look at a few key terms. Ratios compare values, proportions compare ratios. Now, ratios are used to compare two or more quantities in a variety of situations, including baking cakes, mixing cement and diluting concentrated liquids such as cordials or wheat killer. In each of these, the proportion of one ingredient to the other is stated, and it happens the same way every time. Proportion is simply a statement that says two ratios are equal. It can be written in two ways, as two equal fractions, as you can see there, A all over B equal to C all over D, or using a colon, A to B is equal to A to C. Types of proportion. So there is direct proportion, when two quantities are so related that an increase in one causes a corresponding increase in the other, it is said to be direct proportion or directly proportional. Then you have inverse proportion. This is when two quantities are so related that an increase in one causes a corresponding decrease in the other, and this is called inverse proportion. Also, of course, you could have a decrease in one cause an increase in one, vice versa, so that's fine. Scale drawing. Now, a scale drawing is exactly the same shape as the real thing, just smaller. All right? Making a scale drawing is like shrinking an object many times so that it can be shown on an ordinary piece of paper. The sizes shown on the scale drawing will be the same in proportion as it is in real life. What does that mean? It means that if you have a wall that is half of the room or half the height of another measurement, it is the same way if you were to step into that building when it is built from that scale drawing plan. You can also take measurements from scale drawing and work out the actual measurement from them. All right, some more points on scale drawing here. So we're going to do the first scenario. On a map, the scale 1 to 75,000, the distance between two tones is represented by a line 6 centimeters long. What is the actual distance? So let us just look on the board for a short while. So the first thing you want to look at is what a scale is. And I want you to just remember that when you look at a scale, whatever unit is on the scale drawing, whatever unit in the ratio. So if this is 1 centimeter, this represents 75,000 centimeters. So I want you to pay attention to that. So as you can see, there's no unit there. It says that the line is drawn 6 centimeters. So we have a line, and it is 6 centimeters in length. What is the actual distance? So what is the relation with this 1 and 6? So we can now look at another ratio. So we're now going to look at it proportionally. So this would have been 1 times 6 to get it to 6. So therefore, we also must multiply this by 6 to get the measurement that we're looking for. And that would be, so we have 1 times 6 is 6, and this would be 450,000. So what we're saying, for 6 centimeters, it is equal to 450,000 centimeters. Now, we really don't talk about those centimeters, 450 centimeters in real life. So it would be, you would simply convert this to a unit that we'd conventionally use. So let's convert it to meters first. So we have 450,000 divided by 100, and that would give us, so we get 45,000, yes, 4,500, that would be meters. And then we can now further convert it to kilometers by dividing this by 1,000. So we're going to put that here, divided by 1,000, and that would give us 4.5 kilometers. So what we're saying, if you look on the drawing and you're using the scale 1 to 75,000 on this, that's the scale. Where you have a line that measures 6 centimeter, the line will be multiplied by 6 to get it. 1 would be multiplied by 6 to get it to the 6 centimeter. You'd have to also multiply this part of the ratio by 6, giving you 450,000. You would now convert this centimeter to meter first, which gives us 4,500 meters, and then later convert the meters to kilometers, which that's how we talk about actual distance, when we talk about larger distance. So on the map, the line that represents 6 centimeter would represent 4 5/10 kilometer in actual distance. All right, ratio, let's look at a ratio scenario here. A catering assistant uses 3 spoons of lemon juice to 12 spoons of water. What is the ratio in its simplest form? So here you are pretty much just seeing your ratio, and you want to just make sure that when you look at the question, you see exactly the ratio that they're giving. And this is pretty easy thing. So they're saying you use 3. And remember when we started ratio, we spoke about order is important. So the first thing that is given is lemon. I like to write it down first so I know what I'm comparing or what I'm putting in ratio. Lemon juice to water. So what is the quantity that represents lemon juice? 3 spoons. I can write the spoons if I want, because I can, but I don't have to because the unit is the same here. To 12 spoons. And you know you don't really see ratios like that, so you can then go 3 to 12. So the ratio is lemon juice to water is 3 to 12. The question says, what is this ratio in its simplest form? So what is it asking? Are there factors that you can, are there similar common factors with the 3 and the 12? Yes. 3 is a factor of itself, and 3 is also a factor of 12. 3 into 3 goes 1 time, 3 divided into 12 goes 4 times. So what we're saying, the ratio 3 to 12 can be simplified to give you 1 to 4. So now it is in its simplest form. All right, let us look at another. So what does this mean? 1 spoon of lemon juice to 4 spoons of water is the same as 3 to 12 lemon juice to water. It's just in a simpler way. So if you're making a smaller, if you're making a glass of, I guess, what is that? Lemon juice, lemon water, you could use a 1 to 4 ratio. All right, guys, using ratio here again. Sometimes the numbers are much larger than what we just looked at. We looked at a 3 to 12 ratio a while ago. What happens if you have a larger ratio? So you have 36 parts to 96 parts. What would this ratio look like in its simplest form? So again, as you can see, there's no attribute given to the ratio here. So we call these raw numbers. And you have, the ratio is 36 to 96. Now, you don't have to stress yourself. If you look at the numbers and nothing pops out to you, you can always try with your smallest numbers. So you can try with 3, or you can try with 2. So if we try with 2, 2 into 36 would go, 2 into 36 would go 18 times. and 2 into this would go 2 into 9 is 4, 2 into 16, 8, 48. It's not in its simplest form. So we can definitely go simpler. So we can try 2 again. So 2 into 18 goes 9. 2 into this goes 24. I hope I'm doing this right. Okay, now we have 9 and 24. We should know by just looking at 9 that 2 cannot be factorized out of 9. So clearly, we have to leave the 2 alone now. Although 2 is still a factor of 24, you must find a factor for both parts of the ratio. So let's try 3. 3 into 9 goes, what? 3 into 9 goes 3 times. And 3 into 24 goes 8 times. 12, 6, 6, also. Yes. All right. So you could definitely work it down and you'd realize that 3 is a prime. So there is no more factors that can go into 3. And if you can't factorize anything else out of 3, you have to just stop. This is the simplest form. Now, if you're very good with numbers after observation, you could also have recognized that 12 is a factor of 36 and 12 is a factor of 96. And you would pretty much just move from here to 12 into that goes 3. And 12 into 36 goes 3 times. 12 into 96 goes 8 times. So you would have eliminated this process because you would have been quite familiar with numbers and been able to factorize faster. Doesn't make do what you're comfortable with, but of course, you know my saying already, efficiency is key. But once you're comfortable, work the way you can when you are doing your ratio problems. All right, so exam paper. So we have the first question up is a journey takes 3 hours at an average speed of 30 kilometers per hour. How long will the journey take at 40 kilometers per hour? All right, so you want to read this question and make sure you are getting exactly what the question is giving you. All right, so let's see. So the journey takes, so the time, we know we get some time because the time is 3 hours. All right, then it says the speed, the average speed. So we have the average speed is, no, so speed, I spell with 2 P's, speed spell with 1. Speed is 30 kilometers per hour. Great. So we have the speed and we have the time. We don't have the distance. We can now use a formula, which is speed is equal to. So it is important that you know these formulas, you know. When you're looking at speed time, you need to know the relationship with speed, time, and distance. So speed is equal to distance divided by time. As you can look here, your unit for speed is kilometer, which is distance, per hour, which is divided by time, and time is in hours. Great. So we can now transpose this formula to find distance. So we now can say, and I'm just going to keep the speed on this point here. We can multiply both sides by time if we do that. So time there, and then I'm going to put it below it. Let's not come. Over time multiplied by time. I'm just putting this here for you to see what happens to the time there. So distance is equal to speed multiplied by time. All right, what is the speed? We have the speed and we have the time. So speed is 30 km per hour multiplied by 3 hours equal the distance. And I'm just going to use D there. So 30 times 3, that's 90 kilometers. So we have the distance traveled would be 90 kilometers. So with that in mind, we can now use that to calculate. So we're going to go back on screen where we can now use that to calculate what is the same formula. So we have the speed, we have the distance. So now we want to make time the subject of the formula. So if we're using Let's use this one here. We're going to use this and let time be the subject. So speed is being multiplied by time here. Let's undo that, and you now have speed multiplied by time. All right, I want to write it out because I don't want to take it for granted that we're all where I am at. All right, so I want time by itself. I'm going to divide by speed on both sides, giving me time is equal to distance over speed. All right, great. So I want to find time denoted by the T, distance. All right, how many 40 can I get from 90? How many groups of 40? 2. I can get 2 whole groups of that, and I have 10 40th left. Yes, I would like the fraction. Here we'll take care of that. So now I have, this is the time that I have. I can simplify my 10 40th. So I have 2, 10 into 10, 1 time, 10 into 40 goes 4 times. So what I have is 2 1/4 hours. Remember what I said to you previously? The hour is 15 minutes. So this can be rewritten as 2 hours and, let's write the hour there, and 15 minutes. All right, that don't look like it's spelled right. Let's just abbreviate that. There you go. So it's 2 hours and 15 minutes by time. You can manipulate that formula. You can transpose that formula if you're given any 2 of the parts of the formula. So if you're given the speed and the distance, you can find the time. If you're given the time and the distance, you can find the speed. You pretty much get what I'm saying. All right, so here we've worked out that it will take you, and think about it, you're traveling faster. So when you were traveling at 30 kilometers per hour, it took you 3 hours. Now you're traveling a little bit faster, not really speedy, but 40 kilometers per hour, you should take less time. And the math would prove it. You have now taken 2 hours and 50 minutes, less than 3 hours, to travel the same distance. And we have that there on screen. Now, this is, what kind of proportion is this? This is inverse proportion, because the speed is increasing, but the distance is, no, that's not right. It is inverse proportion because the time is decreasing as the speed increases. And remember, inverse proportion, one increase, the other decreases. Great. All right, let us look at another question. Okay, so this would have been 2. We've worked this already, and that would have been 2 hours and 15 minutes. Let us look at this one now. So we have 60 grams of sugar. What is the ratio of sugar to butter? And it is pretty much a very straightforward question. It is asking you to just give me a ratio for the sugar and sugar to butter. And I've always said to you, put your sugar, put what you are comparing. Ratios compare quantities. So it's sugar to butter. All right, what measure or what quantities do you have of sugar and butter? So the sugar is 50. And they're both grams, so no need to put it in. So it's 50, and the butter would be 100. Now let us look at the options that they would have given you. A would have been 1 to 2, B would have been 2 to 1, C would have been 3 to 1, and D would have been 1 to 50. Now when you look at your ratios here on the board, 50 to 100. You don't see none of that. So clearly, they're asking you to simplify this. So 50 and 100. What is the largest common factor? 50. 50 goes into 50 1 time. 50 goes into 100 2 times. So the ratio of sugar to butter is 1 to 2. Not 2 to 1, because sugar must come first, and sugar is 1, butter is 2. So remember that. So don't be careless and put, because you see 2 and 1, anywhere you just select one. The correct option would be option A. All right, and we've done that already on the board. And this is just pretty much simplifying. Sorry, this is just simplifying ratios, all right? And this is comparing the quantities, comparing two different quantities, all right? So now we have another one. A baker uses 4 tablespoons of baking powder to bake a batch of 3 dozen cookies. How many tablespoons of baking powder will he need to bake 9 dozen of the same cookie? Now let's do this one on the screen. Now remember, so your options are there. We're not even touching those options yet. But let's think about it. The baker uses 4 tablespoons of baking powder to bake 3 dozen cookies. How many tablespoons of baking powder will he need to bake 9 dozen of the same cookies? You should realize that the first ratio you have is 4 to 3. All right? Now 9 is greater than 3. So you must expect an increase. So if you're baking more, you're going to clearly need more ingredients. So let's look at it. So we have to get to the 9 dozen, we're going to multiply the 3. Or I should say the relationship between the 3, the first ratio, the 3 and the 9, would be being multiplied by 3. So 3 threes gives us 9. You also multiply your 4 by 3, gives us 12. So your new ratio is 12 to 9. That means you need 12 tablespoons of baking powder to bake 9 dozen cookies. And it stands to reason. You use 4 tablespoons for 3 dozen, you must use more tablespoons for more dozens. Option B, and this is direct proportion because as one is increasing, so is the other. All right, so we're gonna look at some key points as it pertains to when you are given an exam question. What are you looking for? How do you approach this question? So read and understand the problem. That's the first thing that you should do. Identify or define what is given. Determine what is required. And simplify the ratio, apply the ratio, figure out if it's direct or inverse proportion. Then you solve for what is required. Also, you can pay attention to the options that they give you. So if you need to simplify, you can definitely do that.